Okay, let's look at this matrix here. And so far we've seen how we can swap rows, right, using this matrix, right? If we swap rows here, what does it do? It swaps rows in the product, right? Or in the whatever you're multiplying by. So this acts on whatever it's being multiplied by, right? So we've seen this in mapping, right? So hopefully you're starting to see the connection between this H matrix, right? What the representative matrix did. So what this is doing is if we swap rows here, it'll swap rows on the matrix that's being multiplied, that it's multiplying. We've seen that if we have a 3 here, it multiplies that row by 3. Now what about adding rows, right? So let's see what happens here. What if I wanted to do what? Let's do -2 times row 2. Oops. Plus row 3. What would happen? Well, let's see. So -2 times row 2, that's going to give me what? -2 here, 0, -2, 0. We're going to add it to row 3. So that means what? These first 2 rows are going to be left unchanged. And then what's going to happen here? This is going to be 0, -2, 1. Okay, so what's so special about that? Okay, well, so Mr. C, you just went ahead and did the operation, right? That we've always done, right? This is nothing new that we've been doing from this very beginning. But now, watch what happens here. Okay, so I did this on the identity matrix to get this. But see what happens here. Now I'm going to use this on another matrix. Let's use this one. On the matrix, let's use the matrix that we were using before. Right, so this is where we're at. Oops. Okay, so this was the matrix from the last example where we ended, right? We switched the rows and we got this. Okay? Before that, we multiplied this by 3 to get rid of the 1/3. Okay, now watch what happens. This matrix here is going to perform this exact operation. This elementary row operation. Watch. So it's going to leave what? It's going to leave the first 2 rows unchanged. Right? This row, this 1 is going to copy row 1 and it's going to copy to row 1 of the product. This is going to take row 2 and it's going to copy it into row 2 of the product. So that's going to stay the same. 1, oops. Oh yeah, 1, 0, 2, 0, and then 1, oops, 0, 1, 3, -3. Now what is it going to do to this second row? Well, it's going to take twice -2 times what? The second row plus 1 times the third row. It's going to copy it into the second row. So this here takes the copy of the third row, but it's also going to add negative 2 times the second row. Okay, and you can see that by just saying, okay, if I take this one here, this is 1, 3. This is 1, 3. So if I take first row times third column, I get 1, is that right? Yeah, 1 times 2, and the rest are 0. Or hold on, this is, I'm sorry, 3, 1. Yeah, this is row 3, column 1. I'm sorry, doing the wrong one. This is element, this is entry 3, 1. So I want to use third row, first column. So it'll be 0, 0, and 0, which means I'm going to get 0. Now I'm going to do this one. This is 3, 2. Now I'm going to do 3 times the second row. So all I'm going to do is take this row and I'm multiplying by each column to get these. So let's do that. So next one is going to be this times this. So it's going to be 0, negative 2, right? 0 times 0 plus negative 2 times 1 plus 1 times 2. Isn't that taking 2 times this plus this? So that's negative 2 times this, which is negative 2, plus this, which is going to give me 0. Now I'm going to do the next one. 0 times this is 0, plus negative 2 times 3 is negative 6, plus 1 times 1 is 1. So negative 6 plus 1 is negative 5. Now I'm going to do the last one. So it's going to be 0 times 0, 0, plus negative 2 times negative 3 is positive 6, plus 1 times 1 is 1, so that gives me 7. And now, notice what happened. 2 times, negative 2 times the second row plus third row. So negative 2 times 1 plus 2 is 0. Negative 2 times 3 plus 1 is negative 5. Negative 2 times negative 3 is positive 6 plus 1 is 7. It does exactly the same thing. So doing this operation on the identity translates into doing the exact same thing on any matrix. All right? Have a great day.